Yeah, good evening, everyone. In our last videos, we had a very clear discussion about how we can able to perform various bit level operations. Okay, how you can able to perform various bit level operations. We have seen very clearly. So as a part of continuation, then after that, we had a very clear discussion about hash tables also, how you can able to create this hash table data structure, how you can able to work with this. Okay, so we have seen very clearly. Yeah, some other day I will take one what you can call doubts clarification section. There we will talk about that. Okay, so next, in detail about this hash table, what are the various collisions happen, so how you can able to resolve that, all these things we had a very clear discussion in our previous classes. Today I'm going to start. Okay, yeah, today I will upload that. So today we are going to start a new concept called tree data structure. Okay, today we are going to talk about a new data structure called tree data structure, which is very, very important. Okay, so maybe you have seen these kind of data structures in several aspects, like in C language also, we are using these trees, and even in C++ by using C++ a programming language also we can implement this. Like we have wide variety of implementations are there for this. Now if we want to talk about introduction to this, okay, just let me talk about the definitions and where we can use all these things. First of all, it is a non-linear data structure, right? It is nothing but non-linear data structure. Non-linear data structure means what? The data is not going to be arranged in 52, 53 video is related to Python, not related to the hash table. Which one? In recorded session, 1 minute, let me check. One second, sir, let me check. '52 and '53. Okay, I will check it once, sir. Today I will check with admin team. Okay, let me write that. Okay, I will check it with admin team today. Okay, don't worry. Yeah. 53 is a special string class, 52 is linked list. Okay, I will check it with once admin team, sir, and I will upload. Okay. One second, now itself I will make a call to them because okay. So let me talk about here tree data structure. It is non-linear data structure. That means the data is not in a linear state. Okay. And this is best suitable. This tree data structure is best suitable for search operations. If you are performing any search operation, the best data structure what we have here is nothing but tree data structure. So tree is the best suitable for search operations. Remember carefully, when compared with remaining data structures, tree data structure is going to give best results for searching operations. And it is always used to represent hierarchical, okay, hierarchical data structures, hierarchical relationships. So if you want to maintain any hierarchical relationships like parent to child like that, so in such cases it is always recommended to go for this tree data structure. Sir, I will take some examples. Like I want to go for, sir, banking application. If you take any banking application, how you can represent that hierarchy? Sir, on the top level, okay, on the top level, consider this is nothing but banking like this I have, okay, banking system. So this banking system is divided into main two sub trees, I can say sub trees are two categories. The first one is nothing but it is a concentrating on customer, and the second one is nothing but it is a concentrating on employee. In this customer also, again, so two types of customers may be possible. Even in the employee also, sir, two types of employees can possible. Sir, here this customer can be a regular customer, okay, or this customer can be a new customer. So this employee can be manager, or this employee can be cashier like this. So this hierarchical representation, this banking system is divided into these two modules, and this employee module is again divided into two sub modules, and this customer is divided into two sub modules. Have you observed? This kind of technique is called as, sir, banking system, banking management system. Okay. So like this we can represent. Sir, how you can able to treat this banking management system in the form of a tree, right? So here this top level tree is there, right? It is called as root, top level. And for that we have two childrens are there, and every customer is again divided into two types, and every employee is divided into again two types. So such type of things, hierarchical representation, if you want to maintain, then always recommended to go for this kind of tree data structure. Next, one more example. Sir, I want to go for software, okay, software related terminology, IT sector related terminology if I want to maintain. Now consider for information technology IT sector. So manager will be there on top level, okay, manager will be there on top level. He is going to control everything, okay. So this manager is dividing the tasks into for three persons, okay, three categories will be there under that. So what is the first category here is, maybe I'm going to take it as a team lead. So developer, okay, developer lead, developer team lead will be there, and maybe designer for the application, and testing team will be there. So testing team lead will be there here, okay. Sir, now under this testing team lead, so multiple persons will work, right? So tester 1, tester 2, like that. Even for developers development team also, multiple developers will be there, okay. So here I'm going to maintain, so developer 1, okay, developer 1, and here this one is considered as a developer 2, and this one is nothing but tester 1. Okay, and second module is nothing but a tester 2. Like this we can have. Sir, have you observed these kind of things are represented always in a hierarchical manner? Okay, these kind of things always represented in a hierarchical manner. Sir, some people may have a doubt. Sir, tree means compulsory it should have only two children, right? But why this manager root node is having three children? No. So a node can have any number of children. That is the concept of tree. A node can have any number of children. Sir, here the top level data structure which I am explaining now is a tree. Then later we will go for binary trees. Binary trees. Then later we will go for binary search trees. There you will get the difference between these things. Okay, but as of now I am talking about a tree. In the tree a node can have any number of child nodes. Okay, so this one I can consider it as a, sir, software management system. Like this I can take. Okay, sir, even if you want one more example I'm going to give. Sir, in our system, in our operating system, the file system is designed in this hierarchical manner only. Okay, how the file system is divided? Sir, I have C drive is there here. Okay, I have C drive is there here. Number of folders will be there in this. Like this may be one folder, this may be another folder. Okay, again it is divided into different subfolders. Again it is divided into some subfolders. Like that we may have. Sir, consider this is nothing but I can say program files. Okay, and this one is nothing but Windows related thing. And here I am talking about this one as a MS Office. Okay, and this one is nothing but something like Java application. So this one is nothing but anyway Python or any other thing folders. And this one is nothing but paint application. Okay, and this one is nothing but a calc application. So this one is nothing but notepad application. Like that all these parts are under Windows. Like this we have. Like this we have. Sir, it is nothing but a file system in every operating system. Maybe the terminologies are different. So file system hierarchy in operating system. Like this we can have. Sir, even in our family also. Okay, if you take our family, so family tree will be there, right? Family tree, like if you are going for any registration for land or something like that, they will ask family tree. Something like 1b will be there. If you people remember, in that 1b, who is the parent for you? For example, if the land belongs to you, who is your parent? So for that parent, how this land came from, whom they have purchased. So from that whom they have purchased, like that minimum they are going to maintain 4 or 5 backgrounds. Okay, so something like ancestors, something like that. So here I can say this family. Okay, maybe mother and father will be there. So that is divided into, okay, so father and mother, grandparents. Let me take a grandmother. So grandfather, father, and then mother. Okay, again for them children will be there. Okay, and here uncle and auntie, something like that we have. And here also it is divided into, so multiple parts, multiple child will be there, cousin, cousin 2, cousin 3, like that. So family tree also is going to maintain this kind of tree data structure. Okay, file system. So family tree is also comes under tree data structure. Sir, in real time, how you can able to represent this tree data structure? We will see how you can able to represent and how you can create the program. So many n number of applications are there for this tree. Whenever, if you want to maintain such a type of hierarchical structure in your project, always recommended to go for this tree data structure. And remember only one point, where we can use a tree data structure oftenly, only two parts, only two important points. One is if you want to represent the data in hierarchical manner, that is one point. Second point is nothing but what better search operations will be there in this. So these are the two reasons why we are going for this tree data structure. Okay. So now anyway, I will give the official definition, how it is represented, all these things. Can you please confirm up to this? Do you have any doubts in this introduction? Do you have any doubts? Please confirm. Okay. Right. Now I will go with the official definition of a tree, how we can able to define what are the tree terminologies. Okay, we are going to use some words like root node, child, parent, leaf node, height of the tree, level of the tree. Okay, so successor, predecessor, okay, siblings. Like we are going to use a some terminologies. Those things we are going to discuss one by one. I request everyone to please respond clear up to this. Only three members responded. What about remaining people? Please respond. Right. Just please wait for 2 minutes. I will be back. Please wait for 2 minutes. Yeah, welcome back. Yeah, Vishal, I will talk with admin team so that problem will be resolved by today. Okay, right. Next, sir, tree is a tree is a finite set of one or more nodes. A tree is nothing but finite set of one or more nodes such that so what is the first point here is there is a there is a specially designed there is a specially designed node called root. There is one specially designed node will be there, and that node is called as root node. Second point, remaining nodes. Okay, remaining nodes are partitioned. Okay, remaining nodes are partitioned into n greater than or equal to 0 disjoint sets. Okay, remaining nodes are partitioned into n greater than or equal to 0 disjoint sets, and these are called as subtrees. Okay, so if you want, let me take one example, so diagram, so that you can understand well. So I have a set is there. Yes, a tree is nothing but I can say it is a finite set of one or more nodes. Sir, this is one node. Okay, this is one node. Let it be T0. Only one node also we can have. Okay, if you have one node means what? So this node is also considered as a tree, or a node that can have one child. Yes, it is also a tree. Okay, sir, a node, sir, can have two child also, no problem, two children. So T1 and then T2, two children are there, no problem. In this case, no children. In this case, only one children is there. In this case, two child nodes. Sir, now T0, sir, it can have, so T1 one child, T2 another child, T3 another child. Like this also we can have. Or your node T0, your root node can have, so T1, okay, and then T2, and then so T3, and then Tn. Like this also we can have any number of nodes it can have, sir. So this is called as what? Tree data structure. Okay, so tree means what? It is a finite set of nodes. It is a finite set of nodes. Sir, we can have a single node, or you can have a node with one child, or a node with two child, a node with three child, or a node with n children. Like that we can have. So these kind of things are called as tree data structure, sir. Sir, okay, fine. But what is the general meaning of tree? Maybe this diagram you can see. Suppose if you take a normal tree, sir, it will be like this, right? Just for your understanding purpose, I am drawing, sir. So consider this is nothing but a tree. Okay, this is nothing but I can say a tree. So maybe this diagram is not good. Please try to understand. Okay, and these are nothing but roots of the tree. Like this you may have. This is general tree, sir. This is general where this part is called as what? How you can able to pronounce this? We will call it as a roots. Okay, and these are called as branches. Okay, in our normal terminology, these are called as branches. Sir, what about these one? These one are called as leaves, leaf nodes, leaves. Okay, same structure we can maintain in normal tree data structure also, but this complete tree we are going to reverse. So here we will have a node, and here it is having one more node. So here it is having one more node, and this one again can have one more node. This one again can have one more node. This one can have one more node. Like this we can represent. Okay, sir, here do you know this one is called as a root? In general tree, root will be there at the bottom, but while representing in the system, we are going to represent the root as a top. Then, sir, this node, this node and this node. These three nodes are called as leaf nodes. Leaf nodes means what? The nodes which is not having any child, and these connections are there, right? These connections are called as branches. I'm representing with our real terminology. Okay, anyway, later these are having a separate names are there. I will discuss about those names later. Okay, so this is nothing but how we can able to represent a tree. Okay, so this is nothing but how you can able to represent a tree. Now, sir, I want to learn some terminologies. So tree terminologies. Okay, I want to talk about tree terminologies. Sir, for this, I need to take a diagram. From that, I will represent. For example, consider I have one node is there here. Okay, one node is there here, and child node one. So here maximum you can expect a diagrams. Okay, so this is the root node connected with these nodes. Okay, so I'm giving this node name as a, and this node I'm giving B, and this one is a C, this one is a D, this one is nothing but E, this one is nothing but F, this one is nothing but G, and this one is a H, this one is I. Just I'm giving labels for these nodes. Okay, now, sir, I want to represent some terminologies. What is the first terminology here we have is root. Sir, what is the root of this tree? Have you observed? It is nothing but a unique node which is not having any incoming edges. In this diagram, you can see every node is having incoming edge. Incoming edge means what? Something is coming to it. Sir, like if you take B, from A, something is coming. If you take E, something is coming. If you take H, something is coming from D. If you take C, something is coming from A. Like that, all the nodes are having incoming edges except A. Okay, sir, hence A will become root node. Okay, hence A will become root node. Sir, what is mean by root? What is the definition of this root node? Very simple. Sir, it is a unique node. So which is not having incoming edges, Example, in this diagram, A is nothing but root node. Now I want to define a node. Okay, sir, it is nothing but fundamental. It is nothing but a fundamental element of a tree. Okay, so each node has data and two pointers. Data and two pointers. Sir, that may be point to null or its children. It's a children. Like this we have. So in this example, so A, B, C, D, E, F, G, okay. So H, I, all these are nodes only. All these are nothing but nodes. Sir, node means what? Everything which is having incoming edges, outgoing edges, or which is having two pointers. So these things are called as node. Even in our linked list, we are using nodes, right? Same style here also. Sir, all these things, A to I, everything will comes under a node here. Okay. Next, I want to talk about edge. What is the meaning of edge? Sir, it is a fundamental. It is a fundamental part of a tree. Okay, so use it to connect two nodes. If you want to connect two nodes, then what entity we are using for this, it will become an edge. In this diagram, A to B, is it a edge or not? Yes, A node and B node is connected with one link, that one line, that is called as edge. Sir, A to C is an edge, A to D is an edge. Sir, B to E is an edge. So next and after that, B to F is nothing but an edge. So B to G is nothing but an edge. So E to I is nothing but an edge. D to H is nothing but an edge. Sir, is there any edge between H to I? No. H node is independent, I node is independent. There is no connection between these two nodes. So here edges means what? AB, okay, we can say AC, we can say AD, and we can say BE, and we can say BF, and then we can say BG, okay. Next and after that we can say EI. Sir, all these things, okay, EI and then so DH, all these things will comes under edges. Edges means what? Something connected between two nodes. Sir, right. Next, I want to talk about path. So what is mean by path? An ordered, okay, an ordered list of nodes, an ordered list of nodes, so that are connected by edges, that are connected by edges are called as a path. Example, sir, I need a path from A to G. I need a path from A to G. So if I want to move from A to G, what path is there? Have you observed? A to B, we have to travel, and from B to G, we have to travel. This is called as a path. This is called as a path. Path means what? Sir, from root node to that node, how you can able to travel. For example, if you are asking, what is a path from A to I? Sir, A to I path is what? First, we have to move to A to B, and then from B to E we can move, and then from E to I we can move. Okay, like this we have. So this is nothing but what is meant by path. Now I want to talk about leaf nodes. Root node means what? The node which is having incoming, which is not having any incoming edges. So leaf node means what? Sir, the nodes which is not having any children, which is not having any children, or so outgoing edges. If you are not having any outgoing edges, those are called as leaf node. In this diagram, is I is having any outgoing edge? No. Is F is having any outgoing edge? No. Is G is having any outgoing edge? No. Is C is having any outgoing edge? No. Is H is having any outgoing edge? No. So these are called as leaf nodes. Okay, leaf nodes. Leaf nodes means what? The nodes which are not having any outgoing edges, or I can say the nodes which are not having any children. Sir, have you observed in this I, F, G, C, and then H? These are called as leaf nodes. Sir, is this 3 to 4 terminologies related to this tree? Is it clear for you people? Because if these are clear, then I will go with few more terminologies. Can you please confirm everyone? Is these points are clear for everyone? Please respond. Right. So next one. Sir, I want to talk about height of a tree. Sir, how you can able to represent height of a tree? So height of a tree is number of edges. Okay, number of edges on the longest path. On the longest path between the root node, between the root and leaf. If you take root node and leaf node, the longest path will be there, right? That is called as height of the tree. Okay, that is called as height of the tree. Okay, so in this example, what is the height of the tree? A to I we can say. A to I. A to I is nothing but height of the tree. Maximum path, maximum number of connectors, maximum number of edges what we have. That is nothing but 3. So A to I. So the number is nothing but 3. Height. Okay. Sir, next. We have level of the tree is also there. Okay. Level of the tree. Sir, what is mean by level of the tree? Very simple. Sir, the level of node or tree is the number of edges, okay, number of edges on the path from root node to that node, root node to that node. Okay, if you take any node, so root node to that node, how many edges are there? So that will comes under level. Maybe here directly we can't represent. I will take diagrammatic representation for this. Okay, so here you can see this is in level 0, because here how many connectors are there? Only 0 connectors are there, and these are there in level 1 because one connector. These nodes are there in level 2. Okay, so this is one connector, this is one connector, two connectors. This is nothing but level 3. Three connectors are there to reach these nodes. Okay, like this we have. Next, sir, I want to talk about the parents. I want to talk about the parent. So we know very well every node is called as a parent except the nodes which are not having any children. The nodes which are not having any children, except that all the remaining nodes will be considered as a parent. So let us talk about that. Node is a parent of all the child nodes, all the child nodes, so that are linked by outgoing edges, by outgoing edges. Okay, so that are connected with outgoing edges. In this example, which are parent nodes? Sir, A is the parent because it is sending data. So B is a parent, C is a parent, D is the parent. Okay. And then E is also parent. But you can skip this A, sir, because it comes under a special node, right? So B, C, D, E are called as parents. Now, so what about the child or what about the children? What about the children here? So nodes that are having incoming edges. So from same node, okay, are called as a child. Same node are called as a child. Example, sir, this I is the incoming edge, right? So from this parent node, okay, otherwise I can say having incoming edges from same node or incoming and outgoing edges, incoming edges and outgoing edges. Okay, these are called as children. In this example, sir, which are children? So B is the children. Okay, sir, C is the children, D is the children, so E is the children. That's all. Sir, remaining, what about I, F, G, H? These comes under leaf nodes. Okay, like this we can represent. Sir, now what about siblings? What about siblings? Siblings means what? So the nodes which are connected with the same parent, right? So nodes in the tree that are children of the same parent is called as siblings. If you take example, sir, B, C, D are siblings or not? Yes. So for B, C, D, we have only one parent is there called A. Sir, we can say E, F, G are siblings or not? Yes, because so for E, parent is B, for F, parent is B, for G also, parent is nothing but B only. Like this we have. Okay, so this is nothing but how you can able to represent. Now, what is the next terminology? What is the next terminology is, sir, ancestor. Sir, what is mean by this one? A node which is reachable, a node which is reachable. So through repeated, moving from so child to parent. Suppose if anyone is asking, sir, what is the ancestor for I? What is the ancestor for I? So what we can able to take? We have to repeatedly move. Sir, I parent is nothing but E, and its parent is nothing but B, its parent is nothing but A. Like for any node, ancestor means what? Parent, parent to parent, parent to parent, like that up to root node you have to visit. Okay, this is nothing but what is mean by ancestor. Can you please confirm up to this? Do you have any doubts? Up to this, do you have any doubts? All these are terminologies only. Please confirm, clear up to this. Okay, right. Next one. degree of node. For any node we can find a degree, the total number of, okay, the total number of subtrees, the total number of subtrees attached to the node, the total number of subtrees attached to the node is called as the degree. Okay, the degree of node, the total number of subtrees attached to the node is called as a degree. Sir, here what is the degree of B? What is the degree of B? How many nodes are attached to this? 3 nodes. That means, so degree of B is nothing but, okay, degree of B is nothing but what? 3, sir. 3 nodes are attached. Now I want to talk about the degree of tree. What is the degree of tree? So the maximum degree, the maximum degree of all nodes is called as degree of the tree, degree of the tree. Sir, what is the degree of this example tree? What is the degree of this example tree? For this tree, what is the maximum node degree? Sir, this node degree is nothing but what? 0, right? So this node degree is 1. This node degree is 0, 0. What is the degree of this node? Maximum degree. That is nothing but 1. Sorry. This node is nothing but 3. Sir, this node degree is 0. This node degree is 1. And this node degree is 3. In this, what is the maximum value? 3, right? So that will become degree of the tree. Okay. Sir, degree of the node means what? Maximum, I mean, the number of nodes attached to that node. But if you talk about the degree of the tree, the maximum degree of all the nodes is called as degree. Next, last 2 terminologies, predecessor. Predecessor. Sir, what is mean by predecessor? Very simple. Sir, while displaying or while traversing a tree, okay. Sir, if a node occurs, okay, if a node occurs previous to some other node, so then, so that node is called as a predecessor. Okay, that node is called as predecessor. For example, sir, if you take a node called C, okay, if you take a node called C, okay, so that node will become predecessor of, um, otherwise I will take E. So if you take a node called E, sir, for this, which is a predecessor of this node E? Okay, sir, this E is nothing but a predecessor to I, right? Before I, this E is there. If you take F, so before G, this F is there. Okay, like that. So predecessor is nothing but what? While displaying, we will see in order, pre-order, post-order is there. Based on that, we can say. Okay, so predecessor of E is nothing but a B. Okay, so before, I mean, B is coming before E. So then B is called as a predecessor for E. Okay, so like this we have, I can say, so E is predecessor. E is predecessor of I. Right? Like this I can say. Next, we have successor is also there. So what is mean by successor here? Same, while displaying, okay, while displaying or while traversing a tree, while displaying or while traversing. So if a node comes, okay, a node comes next to some other node, then it is called as successor. Then it is called as successor. Example, sir, if you take E, sir, E is successor. Okay, E is a successor of. E is a successor of. So next to B we are getting E is a successor of B. Like this we can have. So try to take some trees as an example and practice all these terminologies. Okay. So what is mean by root node? What is mean by node? How you can represent edges? What is mean by path? What is mean by leaf node? Height of the tree, level of the tree, parent node means what? Child node means what? Siblings means what? Ancestor means what? Degree of the tree, degree of the node. So predecessor, successor. These terminologies oftenly we are going to use in our tree data structure. Okay, so this is nothing but introduction to tree. With this we are not going to take any program on this tree, because a tree is the theoretical concept. For this we have some implementations are there, like we have binary trees are there, we have binary search trees are there, we have AVL trees are there. All those implementations we will see very clearly. But remember one point, recursion is the key point for all these things, sir, because easily we can implement these programs once if you know the recursion. Because suppose whatever technique you are following for this is the same technique we will follow for this also, right? The same technique we will follow for this. Are you getting my point? So these kind of things is what, if the problem is very big, dividing the problem into solutions and combining that solutions will give the result. Sir, is it a concept of divide and conquer, right? So that is called as a recursion is the best example for this process. That's why, so if you want to implement a tree data structure, first you should know very clearly about recursion. But of course it is a matter of 2 or 3 steps I will explain while writing the program. Okay, so I think you people got a very clear clarity about introduction to trees. Can you please confirm, do you have any doubts about these tree terminologies? Please confirm. I request everyone to please respond. Any doubts up to this? Right, sir. Anyway, remaining things we will discuss tomorrow. So in the tomorrow's class, I'm going to explain binary trees. What is mean by binary tree? How we can create a binary trees. And we have so many operations are there on binary trees, like creating binary tree, traversing in order, pre-order, post-order. Next, how to calculate level order. So how to calculate maximum element present in the tree, sum of all the elements, minimum element. Okay. So like we have n number of operations are there on the tree, like searching operation, except insertion, everything we are going to cover, because insertion is completely in our hand. We are not going to follow any technique for that. So insertion deletions that we are going to discuss in our binary search trees. Okay. Sir, how we can construct trees? Because we can't traverse anything without having the tree data structure with values. Yes. If you have values, we can construct that process. I will explain, sir. Don't worry. Okay. Suppose if you have some physical representation, how you can convert that physical representation into values. So by taking that values, how you can construct trees, that we will discuss. Okay, don't worry, Vishal. I will take one simple example and I will demonstrate in the tomorrow's class. Okay, right. Tomorrow class is very, very important, because construction of trees, if you are clear with that, then everything is easy, sir. Because in our upcoming classes, everything is small steps by using recursion. So only difficult task is nothing but how to construct the binary trees. That is the difficult task, not that much difficult. Once if you practice with 1 or 2 examples, it will become very easy. Don't worry, tomorrow I will demonstrate that. Minimum 2 to 3 examples I will take. Okay, right, sir. So see you tomorrow. Tomorrow we will meet for the continuation. Okay. Right. Thank you.